Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 2, Section 10, titled Solving One-Step Inequalities by Multiplying or Dividing. By the end of this video, you will have explored the concept of solving one-step inequalities by multiplying or dividing. Presented here are both the solving inequalities by division, using division, and solving inequalities by using multiplication. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and I do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you very much. Okay, Objective 1, Solving Inequalities Using Division. You can solve an inequality that involves multiplication by dividing each side of the inequality by a non-zero number. So here are key concepts, some things to keep in mind. Division properties of inequalities. If you divide each side of an inequality by a positive number, you leave the inequality symbol unchanged. This is an important fact we're going to be talking about here. If you multiply by a positive number, nothing happens to the inequality sign. Something will, though, if you have a negative number. So we're going to look at it from the algebra point of view. It says if A is less than B and C is a positive number, then A divided by C is less than B divided by C. And if A is greater than B and C is a positive number, then A divided by C is greater than B divided by C. So from an arithmetic view, we're going to say 3 is less than 6. So 3 divided by 3, which is 1, is less than 6 divided by 3, which is 2. And that's a true statement. 1 is less than 2. 8 is greater than, right here, 8 is greater than 2. So 8 divided by 2 is greater than 2 divided by 2. 8 divided by 2 is 4, 2 divided by 2 is 1, and 4 is definitely greater than 1. Now, if you divide each side of an inequality by a negative number, this is the key. If you divide by a negative number, you reverse the inequality sign. So, algebraically, that says if A is less than B and C is negative, then A divided by C is greater than B divided by C. So we started off with A less than B, but since we're dividing by a negative number, here's the negative. C is negative, right here. C is negative. The inequality sign reversed. You see it? At first we were A right here, A less than B. Now it's the A divided by C is greater than B divided by C. So the inequality flipped. So that's the same thing. If A is greater than B and C is negative, then A divided by C is less than B divided by C. Again, you are greater than here and you're less than here. You have to flip the sign. Mathematically, 6 is greater than 12. Excuse me, please. 6 is less than 12. So, dividing by a negative 3 now, 6 divided by a negative 3 is greater than 12 divided by a negative 3. And also, if 16 is greater than 8, so then 16 divided by a negative 4 is less than 8 divided by negative 4. So 16 is greater than 8, but if you take 16 and divide it by negative 4, it's negative 4 is the answer, is less than 8 divided by negative 4, which is negative 2. Negative 2 is definitely larger than negative 4. So you see how this flipped. Okay? Okay, here's an investigation we're going to do. It's solving inequalities. So we're going to look at a series of divisions and look at the inequality and see what happens. Explore what happens when you divide each side of an inequality by a number. Simplify each expression at the right. Replace each underscore with a greater than or equal sign. Okay, so they're asked us to do this. So let's go through it and do them. So we have on this side here, we have 6 divided by 3 is greater than or less than 12 divided by 3. So what is 6 to 6 divided by 3 is 2. 12 divided by 3 is 4. So 6 divided by 3 is less than 12 divided by 3. So 6 divided by 3 is less than, and that's not an equal sign. It doesn't make it an equal sign. That's why it's colored differently. 6 divided by 2, and we're going down the line here. You're going to see it. 6 divided by 2 is greater than or less than 12 divided by 2. 6 divided by 2 is 3. 12 divided by 2 is 6. So 3 is definitely less than. So we're going to stay less than, okay? How about 6 divided by 1? 12 divided by 1. Well, is 6 less than or greater than 12? 6 is less than 12. So it's less than. 6 divided by negative 1. Is that greater than or less than 12 divided by negative 1? Well, 6 divided by negative 1 is negative 6. 12 divided by negative 1 is negative 12. Which is larger, the negative 6 or the negative 12? The negative 6 is a larger number because it's further to the right than the negative 12, which is more negative. Think of it that way. It's more negative, but not a greater number. So this is 6 is now greater than, this negative 6 is greater than 12, or the negative 12. 6 divided by negative 2 is negative 3. 12 divided by negative 2 is negative 6. And negative 3 is definitely greater than negative 6. Okay, 6 divided by negative 3 is negative 2. 12 divided by negative 3 is negative 4. And negative 2 is greater than negative 4. So it says patterns. Does the direction of the inequality symbol stay the same as you divide by each side of the inequality by a given number? Explain the reasoning. Well, we've talked about what the reasoning is, but you can see that we came down from divide by 3, 2, 1. When we got down to 1, they were all less thans on the right-hand side, on the left-hand side. Then once we started doing dividing by the negatives, we see it all of a sudden it switched. So now everything is greater than. So the number over here on the left is greater than the number on the right. So, okay, example 1. We have a real-world problem to solve here. It's an engineering problem. An elevator can carry up to 2,500 pounds. Suppose the weight of an average adult is 150 pounds. So that means that we're going to assume in this problem that every adult we're talking about weighs 150 pounds. At most, how many average size adults can safely ride the elevator at the same time? So in words, it's saying the number of adults, right here, the number of adults times 150 pounds, because it's each adult at 150, is less than or equal to, because it said over here, at most, right? We're talking about the at most, 2,500. We're going to let X equal the number of adults, and the inequality that we're going to draw from this is that X number of adults times 150 pounds is less than or equal to 2,500 pounds, because we're allowed to go up to, can carry up to 2,500 pounds. Okay, so now we write the inequality out. It's 150, right here, 150 times X, 150 times X, here's the 150 times X right here, is less than or equal to 2,500. Here we had the less than or equal to and the 2,500. There's the entire inequality. So in order to solve this, we're going to divide each side. We got to get the X alone, remember that? We have to get the X alone on one side or the other of the inequality. We're choosing the left side because it's already there, which means we're going to divide each side by 150. So 150 X divided by 150 is less than or equal to 2,500 divided by 150. Okay, when we simplify this, the 150s cancel out. We end up with x is less than or equal to 2,500 divided by 150 is 16.6. Well, when you simplify this, we're talking about people, and there are no 0.6 people. So that means we have to round this down. We can't round it up. We can't add more people because the highest this can go is 16.6. 16.7 would overweigh the elevator. So we have to round down, and we can round down to the whole number of people. When you round down, at most 16 average adults can safely ride this elevator at one time. So if we to check it, 150x less than or equal to 2,500 right here, put 16 in at the 100 with the 150, and you get 2,400 is less than 2,500. And yes, 16 is a reasonable number of adults. Okay, example 1, check your understanding. So solve each inequality. So I'm going to allow you time to do it. Stop the video. Give these 3 problems a try. See what you come up with. When we come back, we'll solve them together. So okay, now that you've had time to solve them and you're back with me, let's give them a try. Let's do A. So A says 4x is greater than 40. So as I always say, look at the inequality, see what you're dealing with. You're seeing it's a greater than sign, and you know that it's going to stay greater than unless we're dividing or multiplying by -1. Since we've got to get rid of the 4 with the x, because we have to have the x on one of the sides by itself, and it's a positive number, it's a positive 4x, we're not going to be switching the sign around at all. So we're going to divide. In order to get the x by itself, we have to divide by the reciprocal of 4, or multiply by the reciprocal of 4, which is 1/4. And we can write that as 1/4 times, we can write it like this. We can say 1/4 times 4x is greater than 40 times 1/4. Just another way of writing it. Or we could have wrote 4x divided by 4. I chose it this way this time. So now, to simplify this, we're going to cancel the 4's. 4 divided by 4 is 1. So we're left with 1x on this side. And that 1x is greater than 40 times 1/4. 1/4 of 40 is 10. 40 divided by 4 is 10. So the answer here is 10. B. So we have a -21. -21 is greater than 3m. So we're looking at the inequality first. We see that there's no equal sign with it, which isn't going to matter in this problem, but you just observe what kind of an inequality this is. It's greater than. We see that we have an m by itself on the right-hand side, which is already more good. We can have it on the right-hand side. And we see it's multiplied 3 times positive, not negative times. And since it's a positive, that means we don't have to worry about flipping the sign. The sign does not flip. Not the sign, but we'll call the inequality does not flip. We're going to divide both sides by 3. And when we do that, we're going to have -21 divided by 3 is greater than 3m divided by 3. Simplifying, 3's cancel each other out because 3 divided by 3 is 1. We were left with m, and we're still left to have the greater than sign right here. And it's -21 divided by 3, which ends up being -7. The sign doesn't change because we didn't divide by any negatives. Excuse me for that. One thing I can say is that if you have, and you want to put the m on the other side, well, let's see what goes on here. It might be interesting to see this. So in order to get the m by itself, we're going to, and have it on the opposite side, we're going to be subtracting m from both sides, right? And we're also going to subtract a -7 from both sides to get the -7 on the opposite side. So when you subtract a negative, you end up with a positive, don't you? So let's go ahead and do this. So we're going to say we're going to negative 7 on this side. In order to get rid of this negative 7, we're going to have to add 7. So 7 minus 7 is greater than m plus 7. Okay, and now we're going to have 0 on this side here. We're going to have 7's cancel is greater than m plus 7. So now we have 0 is greater than m plus 7. Now we got to get the m to the other side, like we said. In order to do that, you're going to subtract it. So now we're going to say negative m is greater than m minus m plus 7. Simplifying, the m's cancel each other out, and we're left with negative m is greater than 7. But in this inequality, we don't want a negative coefficient. We want a positive. We want to say what m is, not what negative m is. We want to say what m is. So in order to do that, we have to divide by negative 1 or multiply by negative 1, however you want to say it. But here's where the magic happens. Once we divide by negative 1, we're going to say what? We're going to say, excuse me, divide by negative 1, we're going to say negative m divided by negative 1 is now less than 7 divided by negative 1. And when we simplify that, it's m is less than negative 7. And if you look here, this m is less than negative 7 here. When we go up top, what was this? Where was it? Oh, here, negative 7 is here. Negative 7 is greater than m. It was our solution. Negative 7 is greater than m. When we switch sides, it now says m is less than negative 7. It's the same thing, right? Negative 7 is greater than m up here, and m is less than negative 7 down here. It's the same statement, just written differently. But you see what happened? The inequality moved. It switched from pointing as greater than to less than. Let's do C. 36 is greater than negative 9t. Well, right off the bat, we're going to do this, what we did over on the other side over here, right away. We're going to leave the t where it is, though. We're not going to move it, but we're going to divide by, we've looked at its inequality is greater than, 36 is greater than, we're going to divide by negative 9. Okay, that's going to get rid of the negatives and get rid of the 9s and the negatives all at the same time. And we're going to 36 divided by negative 9. Okay. Since we've divided now both sides by negative 9, this is now positive. It's switched. We've divided, so now we are negative. So this is now 9 times 4, right? So we have negative 4 is now less than t because the 9's canceled. Okay, objective 2, solving inequalities using multiplication. You can solve inequalities that involve division. So let's take a look at what we've got going on here. Okay, let's look at the algebra side first. If a is less than b and c is a positive number, then ac is less than bc. The inequality did not change. If a is greater than b and c is positive, then ac is greater than bc. Numerically, it looks like 3 is less than 4, so 3 times 5 is less than 4 times 5. 15 is less than 20. 7 times 2, or 7 is greater than 2, so 6 times 7 is greater than 2 times 6, or 6 times 2. So 42 is greater than 12. Okay? If you multiply each side of an inequality by a negative number, you reverse the inequality symbol. So in algebra, if a is less than b and c is negative, then ac is greater than bc. The inequality switched. You see that right here? The inequality is now a greater than, it used to be a negative, a less than. If A is greater than B and C is negative, then AC, A times C, is less than B times C. If we look at it in terms of numbers, 6 is less than 9. Yes, it is. So 6 times negative 2 is now greater than 9 times negative 2. 6 times negative 2 is negative 12. 9 times negative 2 is negative 18. And negative 12 is greater than negative 18. 7 is greater than 5. So 7 times negative 3 is less than 5 times negative 3. 7 times negative 3 is negative 21. 5 times negative 3 is negative 15. And negative 15 is definitely larger than 21. Or you can say 21 is less than negative 15. Negative 21 is less than negative 15. Okay, example 2, multiplying to solve an inequality. So we start off here with t divided by negative 4 is greater than or equal to 7. Okay, so what we do here is we're going to, in order to get rid of the divided by negative 4, we're going to multiply both sides by negative 4. That's what we did here. And then when you do that, you see 7 times negative 4 on this side. Since we multiplied each side by a negative number, you see we've switched. It was greater than or equal, now it's less than. So t, which is over here by itself, t is now less than or equal to negative 28. It flipped because we multiplied, or in this case multiplied by a negative number. Okay, example 2, check your understanding. Solve each inequality. And we're going to do just like we've done before. Go ahead and look at this. Stop the video. You know what to do. Stop the video, try these, and come back when you're ready and we'll work them together. Okay, now that you've completed your work, let's do them together. Starting with A, m divided by 4 is greater than or equal to 2. So what do we have to do here? We have to multiply. We're dividing, so we have to multiply now each side by 4. To get the m by itself, we have to multiply the m times 4, because 4 divided by 4 is 1, and we want 1m. What we're multiplying by is a positive number, so therefore this symbol is not going to change. The inequality, the greater than or equal to, is not going to change. So we're going to multiply 4 times m divided by 4, and that is greater than or equal to 2 times 4. So the 4's cancel. We're left with m is greater than or equal to 2 times 4, which is 8. Okay, let's go on to B. T divided by negative 3, is less than 7. We have the negative. We got a negative, less than 7. So in order to get rid of the negative 3, because we want t by itself and we want t to be positive, we're going to have to multiply both sides by negative 3. Well, here's where that multiplying by negative 3 gets us. So negative 3 times t divided by negative 3 is now greater than 7 times negative 3. I'll do this just like that. So the negative 3's cancel. And we have t is, we flip the sign from less than to greater than negative 21. Negative 21. And finally here, 5 is less than r divided by 7. 5 is less than r divided by 7. We need to get the r by itself. And let's take it a step further. Let's assume we want to get the r on the left-hand side. So it'd be like r is something to a number. So we can right away, let's do it. Let's see what happens. We're going to move this r divided by 7 to the other side. So in order to do that, I'm just going to do it quickly here. We're going to add a negative r divided by 7 to each side. So it's negative r divided by 7. Okay. Now, we moved it there. We're going to move the 5 the other side. And it's going to have, on this side, now it's going to have and this is just subtraction, so this stays the same. I'm going to put the 5 on this side now. Okay? But in order to move it, we had to do a negative 5. We had a positive r divided by 7. It's now a negative r divided by 7. We move the 5 to the opposite side. Nothing changes on the sign yet. Now we have a negative 5. So now what we have is negative r divided by 7. So now we can take and multiply each side by a negative 7. So we're going to multiply negative 7 times, I'm going to put this here like this in parentheses, times negative r divided by 7. And since I'm multiplying both sides by this negative, I'm going to change the sign. I'm changing the sign. And I'm going to say negative 5 times negative 7. And when I do that, these cancel, the negatives cancel, the 7s cancel, and we end up with r. I'm going to move it up here. R is now greater than 35. 5 times negative 7 is 35. Okay? And we got the r on the left-hand side, so that looks nice. Like this one over here. We have the r, the t rather, excuse me, on the left-hand side. T is greater than negative 21. It sounds good. It feels good, and it's also here. M is greater than or equal to 8. It's easier to understand with the variable, I think anyway, with the variable on the left-hand side. Okay? Good.